Today we are here to present our final year project on the topic of secure GANs. Now secure GANs is an AI powered facial imprinting system which basically helps us to reconstruct the damaged face and generate a new face over it and produce possible outcomes which are possible from that masked or damaged image. Mostly we see thefts around us wherein the culprit or the thief tries to hide his or her face, and so our objective for this project is to unmask these faces and construct their real faces back. So the problem statement is we are using GANs, which is a generative adversarial neural network with the concept of image in painting to develop a system which will help the security services to reconstruct the faces of the thefts happened at any places and recover their actual faces back. Now let's just come to the demonstration of this. Now this is our front end wherein let's just start by creating a new account. Now let's just put some values. Now once we have created this account, we'll try to sign in with the account created. Now once we click to login, this is the UI which we have created for this project, wherein you can see the objective where the security services can use this project to reconstruct the faces back. Now let's just get to a demonstration of this project. Now let's upload some images and see what happens. Now as you can see, this is a masked face of one of the individual which we have created synthetically, and now let's just regenerate its face. So as you can see, this is the regenerated output. Although this may be a little blurrish, but with more training, these features can still be improved. Now let's just go to some other images and see how these outputs are produced. Now taking this is another kind of mask which is N95 mask, and now let's just try to produce the face. So as you can see, this is the face being generated from this image. Let's just take another example. Now for this image, let's try and regenerate the face. So this is the actual face constructed from the masked face. So now let's just move on towards the code implementation. So as you can see, this is the path wherein we have loaded all the images, and through this, after which loading, we have done some pre-processing operations. After which we have done some pre-processing operations which includes reducing the size of the image from 1024 to 256 cross 256, after which we had done some resizing and cropping operations and normalizing operations over it. So as you can see, these are the input images path. One is a real image and one is the masked image which we have created for training purposes. From this we are loading the images from the dataset. Now this is the major part of our model, that is the generator. This generator mostly consists of two parts, that is a downsampling and an upsampling process. Since we are using a unit architecture in the generator part, so we have this downsampling and an upsampling part wherein the information is being reduced and most important features are being captured, and then they are tried to regenerate through generator. The major part of this project is we are using this process of skip connections, wherein the information is being passed from the downsampling process, which is of major importance to the upsampling process, so that extra information need not be passed. The few operations which we have done is we have taken the strides of 2 and padding as the same. Along with this, we also have an activation function, that is 10H operation. Let me just show you the architecture of this. So this is the architecture. wherein you can see the input image of the masked person is being downsampled to a size of 1x1, and as you can see these lines moving over, these are the skip connections which helps establish the information path to the upsampling process, which helps us capture the information way more far better. Hence this is known as the unit architecture. Next we come on to the discriminator. Once the image is being generated from the generator, the discriminator's task is to identify whether it's real or not. This majorly helps the generator being trained so efficiently that it tries to generate output which is very realistic. So as you can see in this is the generated output, and this is the target, which is the actual output, and then we train this generator to identify whether the image is real or fake. Now let's just come to the discriminator part of the code. As you saw in the discriminator, we have 5 layers, out of which 3 were downsampling layers, rest 2 layers were with padding. 2 layers were with padding. In this process as well, we had a stride of 2. Moving on. So these are the optimizer functions which we have used. The major optimizer is Adam optimizer in this process, and these are some of the outputs being generated iteratively over 2 lakh steps. These are the model sequences which are being created, and these are the total parameters in the generator which are being learned, that is 54 million parameters are being learned.
Thank you. Thank you.
Now these are the outputs which we have just shown you on some of the images. Well, this was our introduction for this project. Thank you.